This question is about two trains moving along horizontal parallel straight tracks. And the first part of the question, just glancing down, is to draw a sketch on the same axes for the speed time graphs of both trains. So I'll set that up now and do that as I'm reading through the question. So initially both are at rest in a station and level with each other, so they'd both be here at the origin. Just label velocity and time there. At time t equals 0, p starts off and moves with a constant acceleration for 10 seconds up to a speed of 25 meters per second, and then moves at constant speed of 25 meters per second. So if I mark that speed on here and 10 seconds on the time axis, now I can draw the journey of that train. So it accelerates and over to the first 10 seconds up to that speed of 25, and then travels at 25 meters per second constant velocity. At time t equals 20, where t is measured in seconds, train Q starts, so let's draw 20 seconds here. Q has been stationary for this time, and now it's going to start moving. Starts to move in the same direction as P. Train Q accelerates with the same initial constant acceleration as P up to a speed of 40, and then moves at constant speed of 40. So now I can draw the, let's mark 40 on the axis. And now I can draw the journey for P. I need to make sure I get the angle, the gradient of this line, the same as the gradient for the other diagonal line, because that represents the same acceleration for both of these trains. So this acceleration being the same as this. And now I'm just going to mark this Q and this P. And that's part A already done. Part B, find the value of t at the instant when both trains are moving at the same speed. Well, the time when they're both moving at the same speed will be here when they're both moving at 25 meters per second. It took 10 seconds for P to reach a speed of 25, so at the same acceleration it will take train Q 10 seconds to reach the velocity of 25. So that's another 10 seconds here. So we've got the initial 20 plus another 10, which equals 30 seconds. For part C, find the value of t. Now, train Q overtakes P at time t equals capital T after both trains have reached their constant speed. So somewhere along here, I'll mark a T there. They have covered the same distance, because as one is overtaking the other, at that instant they have actually covered the same distance. So we just need to find the distance for both, and on a velocity time graph the distance is the area under the graph. Now for P I can calculate that, so I'll do that straight away. And you can split this up into a triangle and a rectangle to calculate. I'm going to just dive in and calculate it as a trapezium. So it's the area up to here under this first graph. So the base is t and the top is t minus 10. So t plus t minus 10 over 2 multiplied by the height of the trapezium, which is 25. And now if I simplify that, that simplifies to 25t minus 125. For Q, in order to work out the area of the trapezium, I have the base of the trapezium, but I don't know this height here, this length here. So I need to find the time here. So let's just call this T1. Okay, so I know that the height here is 40, and I know what the acceleration is. So and the acceleration is the gradient of this line, and the gradient of this line is 40 divided by this length here, rise over run. So 40 divided by, and this length here is all the way to T1 minus that 20. And I know that the gradient is equal to this gradient here, which is 25 over 10. So rearranging this, I get that T1 is equal to 36. So I'm going to mark that on here. And now I can calculate the area of this trapezium. So the base is T minus 20. And the top is T minus 36. Divide by 2 and multiply by the height of this one, which is 40. And that simplifies to 40t minus 1120. And the distance travelled, as I said, when one is overtaking the other, at that instant they've travelled the same distance. So this distance here will be equal to this distance here. So I just need to set those equal to each other. T minus 125, and that gives me that 15t equals 995, so t equals 66 and a third seconds. Marks wise for this question, there's an understanding mark for each of those graphs for the correct shape. So you must have a diagonal line followed by a straight line for each one. And then for the values correct, so you need to have 10, 20, 25 and 40 to get that next understanding mark. For part B, there's a method mark for just showing your working to show where you've got this figure of 30 from, and an accuracy mark. For part C, there is, just looking at the mark scheme, a method mark for, if I go down to this bit where we've worked out the 36, a method mark for making an equation to work out the 26, and an accuracy mark for that being fully correct. So if it's obvious, an obvious attempt to make that equation, you'll get that method mark, even if there's a small error. And then an accuracy mark for 36. Then there's an accuracy mark for either equation, a method mark for either of these equations, this one or this one, and that would be showing that you're clearly trying to find the area underneath here, and then an accuracy mark for each one, and then an accuracy mark, a dependent method mark for setting them equal to each other, dependent on working out those values up here, and an accuracy mark for 66 and a third.